Hi everyone. So what we're gonna do right now, I'm gonna have a separate video for each of these little concepts because this is kind of tricky. We are solving one-step equations and we're looking at only addition. So this can be really challenging, mainly because it's really hard to think of real world scenarios that you relate to on a daily basis in which you would use this regularly. A lot of the things that you've probably learned so far, like counting how many people are in a group that are going to play tag, multiplying people by, candies or something, like if you're giving out stuff, you can use a lot of these things on a day-to-day basis. We tend not to think, like we use equations, but we tend not to think of our life in terms of equations when you're in grade 6 and 7. So already this seems like a tricky thing to connect to. So we're going to break this down. We're going to go kind of slowly. I'm going to show you a video for each of these four. This is going to be the first video for this one or two, okay? So we're going to do this really slowly. So we have x plus 2 equals 5. The thing about equations is that they're telling us that one side of the equal sign is equal to the other side of the equal sign. And I like to think of it in terms of, this actually only occurred to me the other day, but in terms of like a face. Get ready. This is like, oh my gosh, I already drew a really bad face. Not even. Let's just say a face. It's kind of like drawing a line right down the middle of the face and generally saying this side is equal to this side. And anything we do to an equation, I want you to think of it like putting on makeup. If I'm going to put makeup on one side of the equation, I kind of have to put it on the other side. I mean, in real life, you generally don't put like a lot of blush on one side and you're like, yeah, I'm done. Generally, you're going to put blush on one side and you're going to put blush on the other side. And then you're going to be like, yeah, I'm done. So if I'm going to take away makeup though, in order to make an equation work, like let's say I'm taking off my mascara, I'm not going to only take off one eye's worth and be like, done. Generally, I have to do, if I'm going to take off it on one side, take it off on the other. It's got to be even. So I kind of want you to think of this little face analogy when you're doing equations. It also, here's the funny thing, it doesn't have to be written like this. I could actually have it written as 5 equals x plus 2. I can have whatever's on one side, I can just copy paste, move it over here, and whatever's on this side, I can kind of copy paste and move over here. Because they're saying left equals right. This side equals that side. They are the same. They are worth the same. So when we have a question like this, and even if it's a bigger number, it could be like x plus 2000.4 equals 9000 point whatever, who cares? Big numbers. It's the exact same stuff that we're trying to do in order to solve it. So what we need to do is we need to eliminate whatever is next to the letter, and then we're going to eliminate that same thing on this side. Because again, it's like putting on blush and then putting on blush, or removing makeup and removing makeup. Both sides have to be the same because we want this letter all on its own. And we can technically eliminate the letter here, put it over here. We can move the letter. Most of the time, it's actually easier just to keep the letter where it is and get rid of the other stuff around the letter. So in this case, we kind of have to get rid of this thing here, this plus 2, because we want x all on its own. We want it to say x equals something. We don't want it to say like x plus equals. We want just the x. And again, this is mentally quite a jump, right? If you're not very comfortable with math, this doesn't feel very comfortable, but we can do it. We can do this. So often in math, you're going to hear of things being kind of opposite, right? The opposite of addition is generally subtraction. The opposite of multiplication is generally division. And so we're going to use this concept to deal with this question. I have a positive 2 here, and I need to get rid of it. So I'm going to do the opposite. Instead of positive 2, I have negative 2. And on this side, I'm going to do the same thing. I've seen kids in the past who are like, okay, well, I'm going to do the opposite, negative 2. The opposite of 5 is negative 5. Can't do that. That doesn't work because you can see negative 2 and negative 5, those are different numbers. That would be doing different things to the question, and we can't do that. So I need to get rid of the 2, so I'm going to stick in -2. So on this side, I'm going to have -2, like subtract 2 on this side. Minus, minus, 2, 2. It's the same number. Then I'm going to keep my equal sign down here. I'm going to bring it down. There's my equal sign. So now my equation actually looks like x minus 2 equals 5 minus 2 is really what my equation is. And what I'm doing here, this is called showing my work. There's a couple reasons for this. Number one, if you just write down the answer, it looks like you copied it off your neighbor. It doesn't actually look like you did it. Maybe you're smart enough, you can just do it in your head. But we want to know that you did it. Second of all, what if you did something wrong? If you just simply went, you're like, x equals 12 or whatever it is, we would have no idea. Like what was going on in your brain? How did you get there? But if I saw you go like this, if I saw you go x minus 2 equals 5 minus 5, then as your teacher, I'd be like, oh, I see what you did here. Like you minus, it's the number, but you got to minus this number. So this is why we actually have to write everything down, so that we know what happened, where did we go wrong, where did we go right. So let's just recap where we're at so far. I have to take 2 away from this side to get rid of this 2. This is add 2. The opposite of add is subtract, is take away. So now I have take away 2, subtract 2. If I'm going to write in subtract 2, then I also have to write in subtract 2 on this side. So here I have x minus 2, and now I've got 5 minus 2. I just kind of copied it out again. I'm showing my work. It's like leaving a bread trail, crumb thing, whatever you call that. Okay, so I need to subtract 2 from both sides. So what I'm going to do now is I'm going to have x, so 2 minus 2 is 0. Okay, so that kind of cancels itself out. 5 minus 2 is 3. What I've done here is I've shown my work, and now I can actually kind of rewrite it so x is a little bit closer. I've just shown whoever it is that's looking at my work how I did it. They can say, oh yeah, she got rid of 2 on this side, she got rid of 2 on this side. Sometimes you'll see people write it out lengthwise, like they'll say x plus 2, minus 2 equals 5 minus 2. This to me is a little bit more confusing because I'm like, what do you mean plus 2 minus 2? For me, that's kind of odd. I like doing it like this, but you're welcome to do it how you need to do it, so long as you have your numbers in there and it's clear where they came from and how you ended up there. Another thing you can think about, and this doesn't, let me just write this out, x plus 2 equals 5. So x plus 2 equals 5. This doesn't always work, but sometimes this kind of is a little like a trick almost. The equal sign is like a little threshold. It's like a doorway. And if you take this and you cross the threshold, it becomes the opposite. This is not standardized mathematical notation, having a circle and being like, bloop. But if it makes sense, like this in my mind is how this makes sense, is I'm just going to take this chunk and I'm going to do the opposite on the other side. And once I cross that threshold, it has to become the opposite. So whatever it is here, it's the opposite over here. So I would basically then be left with x equals 5 minus 2. And then I would write x equals 3. That's how my brain makes sense of this. My brain struggles to be like, minus 2, minus 2. For me, that's actually a little bit more confusing. For me, it's easier to take this whole thing, know that when I kind of cross the threshold, it becomes a different sign. Unfortunately, that doesn't always work. So, because it's a trick. Generally, you have to stick with the rule. So, let me show you that one more time. Same format. I'm going to use a different number though, okay? So, let's do this. X plus, 4 equals 9. So this is the exact same kind of question. My numbers are in the exact same place. My variable is in the exact same place. But let's just take a look at how we're kind of supposed to do this. Remember, I need x all on its own. I need to get rid of the 4 so that I can have x, there we are, you can see that, just the x, okay? But I can't just take it away, otherwise then I'm saying x equals 9. Well, if x equaled 9, then what was that there for? That makes no sense. So I have to get rid of this on this side, and I'm going to get rid of it on the other side. So what I'm going to do is I'm going to go like this, minus 4, minus 4. They're both going to have minus 4. So then x is going to be equal to 9 minus 4 is 5. X is going to equal to 5. And I can rewrite it, x equals 5 over here. You can also, though, To me, this looks confusing, but I just want to show you how you could write it if you'd rather. You could have x plus 4 minus 4 equals 9 minus 4. You can do it like this so that you're like, okay, yeah, that cancels itself out. And then you're left with the x comes over here. It don't want that to look like negative x. X would equal, and then 9 minus 4 is 5. So you can kind of write it how you need to, do the notation how you need to, but whatever you do to one side, you have to do to the other. So this is how we handle this question. In another video, we're now finished this one, I'm going to show you the exact same numbers, but what happens when x is right here next to the equal sign, okay?